Hey, what's going on, guys? Mr. Flores here, and this video is going to deal with solving compound inequalities. All right. So what we've done so far is we've solved one inequality, and now we're going to solve more than one inequality, but we're going to graph them together on the same number line. And these are called compound inequalities because there's more than one inequality inside itself. So there's two types. There's an and an or. An and basically means the intersection, or both sides must be true, and or is the union, or only one side must be true. All right. Now, the way I kind of think of these is, let's say there's a scenario in class where in order for you to pass the class, you must be a boy, and you must also get a 90 or higher. So therefore, if you only meet one of the requirements, aka if you're a boy, but you don't get higher than a 90, you can't pass the class, because it's and. You must be a boy, and you must get higher than 90. The or would be, you could be a boy, or you could also get a 90, which means that no matter if you're a boy or a girl, as long as you get the 90, you pass, or as long as you're a boy, even if you get a 0, you still pass. All right? So that's like one quick example, and I'm just going to kind of draw two Venn diagrams, okay, to kind of explain it another visual way, and then we're going to get into some problems. So let's say that A is the red marker, all right, and blue is the B marker. All right. Now, A and B means that both blue and red must coincide. Since A is red and blue is B, A and B is actually just the intersection, because that's what we said. It's where both of these things are true. So it's basically where the blue and the red intersect, which is just in this middle part. Okay? So that's our solution. Our solution is really just this orange outline. All right. It's the intersection. It's where they both meet. Now, the other one, where it's blue or red, is anything that's actually shaded in, because it can be just A and B, or just B. All right. Only one side must be true. All right. So that's how it looks as a Venn diagram. The way it looks when you're solving an inequality, something like this. So let's say we have 6 is less than or equal to x, which is less than 12. All right. Now, say we solved an inequality, and this is where we're at. We're at 6 and 12. All right. Let's just graph this first. The x is less than or equal to 6. All right. So at 6, I'm going to draw it above so we can see something. At 6, we're going to put a filled-in circle, because it's x is greater than or equal to. And since we're greater than, we're going to shade to the right, because going right on a number line is greater than, so greater than 6 is to the right. Now let's go back, and it was also less than 12. So in blue, I'm going to shade the 12, or yeah, for x is greater than 12. So if we go at the number 12, we're going to have a filled-in, we're going to have an open circle. Right, 6 is down there, 12 is there. So at 12, we're going to have an open circle because x is just less than 12. And we're going to shade all the way to the left. All right. So like we said, and is the intersection, or where both sides must be true. So therefore, our actual solution is only where the red and blue overlap, which for this case is the middle. So I'm going to draw in purple our actual solution. We have a closed-in circle there, open circle there, and it's just the middle, or the intersection of our answer. So the actual answer for this one is just where everything's shaded in, everything's covered. All right. And that is the solution for x is greater than, 6 is less than or equal to x, which is less than 12, because this is the only part of our solution that is actually true. All right, so that's an and problem. Now let's look at an or. right? So here we have our critical numbers are going to be -2 and 5. Again, I'm going to graph these separately just so we can see. All right, and this says that 5 is greater than x. We're going to have an open circle at 5 because x is actually less than 5. There's no equality. And it says x is less than 5. All right, so I'm going to shade all the way to the left. All right, now in blue, I'm going to shade the other one. X is less than or equal to -2. At -2, we're going to have a solid circle since it's less than or equal to. And we're going to shade to the left. All right, again, since this is an or, it's the union, where it's only where one side is true. So we only need at least one side to be true. So really, we're just going to shade in all of this. And I always like to put my circles in first, just so we don't mess them up. And we're going to shade in the red, which coincidentally overlaps with the blue. And that would be our answer for 5 is greater than x, or x is less than or equal to -2. All right, so those are just some quick examples. But here's one that's a little more in depth, because we have 3 is less than 2x plus 5 is less than or equal to 12. All right, we're going to solve this one the same way we would as if we only had one inequality, because we want to get x all alone. So if we have 2x plus 5, in order to get it alone, we must subtract 5 first. But technically, since there's an inequality over here and an inequality over there, you must subtract 5 from both portions. All right, so you're left with -2 is less than 2x is less than or equal to 7. All right, and then again we must divide both sides by 2, divide that by 2, divide that by 2, and we get -1 is less than x is less than or equal to 7/2. All right, so what we must graph on our number line is going to be, here's -1, here is 7/2. All right, at 1 we're going to have an open circle because it's x is greater than 1, -1. At 7/2 we're going to put a closed circle since it's x is less than or equal to 7/2. And since x is in the middle, we want x to be greater than -1, but also less than 7/2. So we're just shading in all of the insides. You don't have to shade it like I did before. You did each separately and then looked at it. You can do that, and that's actually good if you're having trouble with these. But in reality, all you have to do is shade or graph the final answer. So for on this one, you could have just given me the purple. You don't have to give me the red and blue. And for this one, well, I already erased it, but it just left with the purple. All right. So that's really all you do. Again, I'll do an or one. Actually, I don't like 7 because I want it to come out nicely. -3x plus 2 is less than 11, or 6x plus 5 is greater than or equal to, I don't know, let's see, 23. All right. Again, we're just going to solve them separately. So subtract 2, subtract 5. So then you're going to get -3x is less than 9, or 6x is greater than or equal to 18. Divide this one by -3. Divide this one by 6. And you get x is greater than -3, or x is greater than or equal to +3. All right. So again, all we're going to do is just graph this on our number line. So I'm going to draw it. Our one important number is -3. Our other one is +3. At -3, we have an open circle. At +3, we have a closed circle. All right, and we must graph where x is greater than -3. So we're going to be shading to the right. Okay, and now when we get to +3, let's see what this one talks about. It says x is greater than or equal to +3, so we're still going to keep shading past 3, right? Because even if we pick a number less than +3, let's say 0, that's still greater than -3, so that still gives us a solution to our one inequality symbol. All right. So I'm going to show you an example, though, where kids usually get tricked, all right? All right, and here's one, and I'll explain why it's a little tricky. Because let's say we get down to a problem, and this is what we come out to. We get x is greater than 3, and x is less than or equal to a negative 3. All right, so we're going to go here, and at positive 3, we're going to say there's an open circle, and x is greater than that, so we're going to be shading to the right. Now the blue one, I'll do this. It says x is less than or equal to negative 3. It's going to be a closed circle, and we're going to be shading to the left. All right. But if you notice, this is an and problem, so we need to find the intersection or both of these things are true. If you notice, there's no overlapping of our two inequalities, so the actual answer is going to be no solution. Because in order for this to be true, it has to satisfy both parts because it's an and problem. But if you notice, you can't have a number greater than 3 that's also less than negative 3, so therefore it's no solution. All right. Guys, the hardest part with these is figuring out your answer, but as long as you draw both inequalities and then know, are you looking for the intersection, aka where both overlap, or the union, aka where both of them are, then it gets really, really simple, and it kind of cuts out some of the clutter and the, I don't know, errors kids usually make. So if you have any questions, there's some problems to go along with this. If you have questions, email me, come find me. Have a good one.